So this demonstration is about a portable VCO-based point-of-care spectrometer. We want to detect the electron spins of samples. The ESR effect is somehow similar to the nuclear magnetic resonance, with the difference that in NMR we detect the spins of nuclei, and in ESR we detect the spins of electrons. So the samples we are going to investigate on are species with unpaired electron, what you can see here. Unpaired electrons possess a spin which we can detect. These species with unpaired electrons are, for example, free radicals. Free radicals are dangerous. They can be inside the body. They are likely to cause diseases like cancer, Alzheimer, and so on, and that's why we want to investigate on them. There are already ESR spectrometers, but the problem with them is they usually rely on a heavy machinery. You need a sweepable electromagnet, which is power-hungry, costly. You need a resonator. You cannot sweep as fast as it is like to be. So therefore we thought about a different detection method, and this is displayed here. We rely on a VCO to generate a microwave frequency to initiate transitions for the spins and to measure them. Our whole system is based on this ASIC, which we designed here. It's a custom ASIC, a VCO, and our sample what we want to investigate is placed on the coil of the VCO, and then we can measure more or less the spins inside the sample. The whole setup is placed in here. We have a permanent magnet instead of a sweepable magnet. What we do, we sweep the frequency instead of sweeping the magnetic field. So I can just show you how it works. We have here a capillary with the sample inside it. It's a standard ESR sample. If I now put it into the magnet on top of the coil of the ASIC, so the sample is now lying on top of this coil, and start a measurement. Within seconds we get a really high signal, and from here we can distinguish the frequency at which the resonance occurs. To prove that we really measure the spin, I remove the sample and do another measurement. And now we don't see any signal at all. Now it's possible to have different samples, and from the frequency where the transitions occur, we can tell which kind of sample we have. To conclude, so we built a much smaller system than the conventional system, including the sweepable magnet, what they offer. So our goal is to further reduce the size, to improve the usability, so improve the sample handling, to be able to really use it in the field. The ASIC I just explained here is positioned on the probe head. You can see it here in the middle of the probe head. We designed some guide rails around the ASIC such that the sample perfectly fits in and lands on top of the ASIC. And this probe head is now positioned exactly inside the magnet, inside the center of the permanent magnet.